looks like chaos, but in reality we look at one of the most complex systems in nature. It seems like each individual knows the fastest way by intuition. It knows it without risking bottlenecks. Ants organize themselves by communication and division of labor. They are solving complex challenges and are able to transport high capacities. But they mostly follow their instinct. This is how major transport systems for large amounts of people are functioning in a non-verbal way. People in movement often cause chaos because each individual has its own needs and ways, and each individual makes its own decision. Human beings don't have a sixth sense, such as ants. For humans, it's more efficient to develop intelligent technologies to organize transportation. In the field of regional planning, the primary goal is the optimal offer and use of transportation systems. People have various reasons for commuting: to and from home, work, for their education, shopping, or sports activities. This leads to different requests on the modes of transportation. Every day, every person has an individual combination of travel purposes. To reach one's destinations, one would prefer attractive and the least time-consuming modes of transportation. The operator will benefit through more efficient use of their fleet and staff. In the field of event planning, the task is to manage transport systems in order to move different groups of clients to their events in time. Well-coordinated infrastructure as well as optimized point-to-point transport systems are essential for the success of major events. Not only vehicle and transport resources are affected by the flow of people, but also the impact of the flow of people and vehicles in hubs and stations is very important for operational concepts. Otherwise, chaotic situations will result in monetary losses for the organizers and sponsors, and also in critical situations for people, especially the spectators and athletes. Not everything can be anticipated. A large amount of data, as well as interfaces to other subsystems, are used to develop and simulate what-if scenarios and emergency cases. ITSOS is capable of fulfilling a large number of case studies. The base of the development of an integrated intermodal transport master plan is the infrastructure network, which is managed in ITSOS with GIS-based information, completed with a wide range of transport-oriented basic data. Based on geographic information systems, the infrastructure network is built up using several layers. Numerous geographic data such as transport infrastructure, residential structures, demographic information and much more are captured, analyzed and actualized in the GIS. Based on the detailed transport network, each transport system can be integrated in ITSOS by routing its individual course. The integrated routing module allows you to create these individual transport lines in an easy-to-use way. Additionally, it allows fast and easy maintenance and adaptation of every considered line. All this is saved in a geo-database. This is the basis for simulations. Well-developed simulation methods are the heart of ITSOS. These simulation methods allow you to simulate realistic distribution of people movements in comparison to all relevant transport systems. The evaluation tools of ITSOS give a highly detailed picture of all relevant information which is requested for decision-making processes and further detailed projects. Based on generalized operating costs and emission data, the user is able to evaluate the costs and the ecological emissions of different case studies. For transport management centers, ITSOS serves as the operational integrator interfaced to several subsystems. ITSOS is not a replacement for natural instincts. It is an effective, efficient tool for transport planning and modelling. ITSOS, the Intermodal Transport Simulation and Operations System.